In this video, I'm going to show you a second method of converting between moles of different substances when given a chemical equation. This is called the BCA method. BCA stands for before, change, and after. I find this method to be really useful in terms of it organizes everything we have in that chemical equation. It kind of connects everything together. So some students find it a lot easier than the previous method. So the instructions are as follows. The first thing you need to do is balance the equation if it's not already balanced, and just write it out. Then identify the given and the unknown. So both of those steps you need to do for all the methods. Determine the mole ratio that you also need to do for the previous method. And remember, the mole ratio is determined by the coefficients of the balanced equation. And then you need to set up a BCA table and solve. So that's the only different step. So in this video, I'm going to walk you through how to do one of these. So this is number 1. Hydrogen sulfide gas, which smells like rotten eggs, burns in air to produce sulfur dioxide and water. How many moles of oxygen gas would be needed to completely burn 8 moles of hydrogen sulfide? So our first step is to balance the equation. So we need to figure out the equation. So we have hydrogen sulfide gas burns in air. So when something burns in air, that means it's reacting with oxygen gas to produce sulfur dioxide and water. So in this equation, we have hydrogen sulfide gas burning in air to produce sulfur dioxide and water. So take a minute, pause the video, and try and balance this equation. I'm going to balance this equation by making a reactants and products chart. So on my reactant side, I currently have 2 hydrogens. I have 1 sulfur, and I have 2 oxygens. And on my product side, I have 1 sulfur, 2 oxygens, 2 hydrogens, and then 1 more oxygen from H2O. So I'm going to try and balance my O's. Notice this O is attached to a 2, which means my reactants have to have an even amount of oxygens. So since this is only 1 O, I'm going to start by making this an even amount. So I'll put a 2 there. Well, now I have 4 H's, and I have 2 O's from H2O and 2 O's from SO2. So now I'm going to balance my H's. So I have 4 on my product side, so I need 4 on my reactant side. But that makes me have 2 sulfurs on my reactant side, so I need to balance my sulfurs. Now I have my sulfurs balanced, my hydrogens balanced, but putting that 2 next to sulfur dioxide made me have 4 oxygens here plus 2 there. So that gives me 6 oxygens. So I would need a 3 here. 3 times 2 is 6. So now I'm all balanced. So now I'm on to step 2. Identify the given and the unknown with their units. So my given, how many moles of oxygen gas, so that's my unknown, moles of oxygen gas, would be needed to completely burn 8 moles of hydrogen sulfide. That's my given. So now I need to determine the mole ratio. So when I'm looking at oxygen gas versus hydrogen sulfide, my mole ratio is 2 to 3. For every 2 moles of hydrogen sulfide, I need 3 moles of oxygen gas. And now my last step is to set up a BCA table and solve. So again, the BCA table stands for before, change, and after. So I'm only concerned with these 2 species because I am given hydrogen sulfide, and I want to find out the moles of oxygen. So I don't really need to worry about my products. So B tells me before. So the question is, how much of each of these species do I start with before the reaction happens? So I'm told I start with 8 moles of hydrogen sulfide. And the question is, how many moles of oxygen gas do I need to start with? So I'm just going to call that X. That's my unknown. I want to figure out how many moles of oxygen I'm really starting with. For my change, this is when the mole ratio comes in. So whenever we have a reactant, we are decreasing the amount of that reactant that we have because it's going to react and turn into a product. So my change is going to be minus whatever the mole ratio is, so in this case 2, and I'm going to say C, minus 2C, minus 2 change, whatever that is. And so similarly, my change for oxygen is going to be minus 3C. So I'm going to lose 2 times something for H2S, and I'm going to lose 3 times something for my oxygen. If I cared about my products, and I'm going to put these in red just so we don't care about them for this problem, but I do want you to know how we would solve for them. With products, unless otherwise stated, we always start with 0 moles. The reaction hasn't happened yet, so none of the products have been produced. But once the reaction happens, then we gain. The change is positive because now we're producing these products. So this would be plus 2C. That 2 comes from there. And this would also be plus 2C. The 2 comes from there. So now I need to be concerned about my after. So this is like a simple mathematical equation that we have created. 8 minus 2C equals something. X minus 3C equals something. Well, if it says completely burn 8 moles of hydrogen sulfide, I'm going to end up with 0 moles of hydrogen sulfide at the end. And I want to end up with 0 moles of oxygen gas as well because I just need the minimum number of moles of oxygen gas that would completely burn my hydrogen sulfide. So now I have a convenient equation. I have 8 minus 2C equals 0. So I can solve for my C. So 8 equals 2C. So C equals 4 moles. So my C here is 4 moles. And you can see that because 8 minus 2 times 4, which is 8, gives me 0. So that makes sense. So now I can plug in my C for this as well. So now I have an equation X minus 3 times 4 equals 0. So X minus 12 equals 0. So X must equal 12 moles. So my answer, my X, is that I need 12 moles of oxygen in order to completely burn 8 moles of hydrogen sulfide. And again, we're not concerned about the products, but I'm going to show you how to do that anyway. So I can take my 4 moles, that's my C, and so that's my C for everything. So if I burned 8 moles of hydrogen sulfide with 12 moles of oxygen gas, then I would produce 2 times 4, so that's 8 moles of sulfur dioxide, and again, 2 times 4, 8 moles of water. So in the end, after this reaction takes place, I would be left with none of my reactants. They totally burn and react together, and 8 moles of each of my products. Go ahead and try number 2, and the next video will allow you to check your answer for number 2.